Okay, let's give this thing a try. Again, here it is. It's an ASAP review for Anatomy and Physiology 1, dealing with the skeletal system. This is going to be one of a series of short review videos on the skeletal system, the tissues, and the general structures. I'll be using, of course, the graffiti pages that are available on the Canvas website as a kind of a tool to help visualize the information that we would normally cover in class, and here we're going to be covering it again on video. So it gives you a chance to double check things and to hear it again, sometimes in exactly the same way. Again, please excuse all the background noises. I'm doing this outside and it's very amateur. But here we launch. Oh, by the way, ASAP stands for as soon as possible, so you can get started learning this stuff as soon as possible. But it would also stand for awkwardly simple anatomy and physiology, awkwardly simplified anatomy and physiology, because that's all this is, just an introduction to the concepts, which you can then better understand when you read through the chapter and look at the other supplemental material. Of course, in class, we'll cover the same information, but this way you get a preview of the material that we're talking about. Again, awkwardly simplified anatomy and physiology. Let's get started. Right off the bat right here, we're talking about the skeletal system. And again, it is a system because it is a group of organs that function together. And there are approximately 206 organs inside the skeletal system. Each bone represents an organ. And we say it's approximately 206 because not everybody has exactly the same number. For some folks, two bones might fuse together, and that's counted as one single bone. For other folks, embryologically, a couple of bones that normally would fuse didn't, and this person would have an extra bone. There's also things called sesamoid bones, which some people might have and others might not. So this number right here, 206, is an approximation. By the way, just for the fun of it, of the 206 commonly recognized organs of the skeletal system, that is the named bones of the skeletal system, approximately 106 are found inside your hands and your feet. And a quick review of that would be that inside your hand, each hand, you have 8 carpals, 5 metacarpals, and then 14 phalanges. So that's 27 bones in each hand, covered quite simply by 3 names. And of course, there's the other hand. So you'd have a total of 27 bones per hand, or 54 bones in the 2 hands together. Now, in your feet, you have 7 tarsals, 5 metatarsals, and then 14 phalanges. So 26 bones in each foot. Or put the 2 feet together and you have 52 bones. So 26, 26, 27, 27, put it all together, you come up with 106 bones inside your hands and your feet. So over half of the named bones inside your body are found inside your hands and your feet. Now, of course, in lab, you go into greater detail as to the names of the 8 carpal and the names of the 7 tarsal bones. But right here, right now, let's keep it simple. Here's something else that keeps it simple. We want you, for the sake of the lecture, to remember that bones are generally divided into 2 categories, axial bones and appendicular bones. The axial bones are those that are located in the middle of the skeleton, sort of like the axis of a wheel, that area around which the wheel would rotate. So in the axial skeleton, you have the bones of the skull, including the hyoid bone. Then you have the cervical vertebrae, thoracic vertebrae, lumbar vertebrae, sacrum. You have the coccyx bone, and you also have the ribs and the sternum. So those represent the axial skeleton. For the appendicular skeleton, those are the bones that are attached to, appendix, or on the edge or attached to, the axial skeleton. And they include the bones of the arm, the bones of the leg, and of the girdles of the body. So you have your pectoral girdles, and that would be the right and left scapula and clavicles. And you have your pelvic girdles, would be the right and left os coxa, made up of those 3 bones, pronounced in so many different ways, such as the ilium, the ischium, and the pubis bone. So Real quickly there, I can remember humerus, radius ulna, and then the bones of the hand, and then the os coxa with the 3 bones inside, femur, patella right here, tibia, fibula, and then the bones of the feet. So the skeletal system includes all these organs. We do subdivide it, we do name the individual organs, but the skeletal system also includes the cartilages, ligaments, and tendons that are associated with it also. Real quickly here, there are 3 basic types of tissue associated with the skeletal system. Basic types. There's the osseous tissue, and in this picture right here of a so-called soup bone shape, we have the outside of the bone. Here's been cut in the diaphysis perhaps of the bone. Here is a potential cavity towards the middle, and here's a more solid ring of material around it. This relatively solid ring of material to the outside is known as the compact, dense, or cortical bone tissue, and it represents approximately 80% of the mass of the bone. Much more detail later on. This region in the middle can be called the spongy bone or the cancellous bone, and the word trabecular is used to represent the pattern of the bone tissue inside this region right here, and it represents about 20% of the mass of the bone. Later we'll come back and reinforce the idea that the word trabecular, coming from the word trabeculae, refers to the pattern, not so much the material, but the pattern. So if you look at the word trabeculae in the index of your textbook or inside a dictionary, it might refer you to the inner lining of the ventricles of the heart or patterns within lymph nodes. It's a word for a pattern. So the word trabecula is sort of like the word plaid. Plaid doesn't tell you what is woven in that pattern, it just tells you what the pattern is. When it comes around to other tissues associated with the skeletal system, that includes cartilaginous tissue. And the 2 basic types associated with the skeletal system are hyaline cartilage and fibrocartilage. Now, of course, we're asking you to flash back to 2401 and remember all the things that you can about hyaline versus fibrocartilage. One of the biggest things, the most obvious things, is that hyaline means clear, and the matrix of hyaline cartilage is relatively clear. It's sort of like smoked glass. You know something's there, there's a color there, but you don't really see a lot of stuff. The lacuna inside the matrix of the hyaline cartilage tend to be round, relatively large. Inside this, of course, are the chondrocytes. So, with hyaline cartilage, a relatively clear, consistent matrix, and the lacuna tend to be relatively round and open. In the fibrocartilage, however, some radical changes. The matrix tends to be fibrous in that it appears to have threads that run through it. I like to make the analogy that this is sort of like smoked glass with bubbles in it. This is like fiberglass with bubbles in it. There's a lot of thread-like material in here, and of course those are collagenous and other types of fibers that are forming bundles woven through the matrix. The lacuna in fibrocartilage tends to be flattened and smaller than lacuna inside the hyaline cartilage. This is related to the idea that fibrocartilage is very commonly found in areas where there's a great deal of pressure. As a quick review of that, here are some places where we find hyaline cartilage in reference to the skeletal system. Costal cartilage. The ribs do not directly connect to the sternum. The first 7 do not directly connect to the cartilage. The number 8, 9, and 10 don't directly connect to the sternum. And 11 and 12, they don't connect at all. But the bridge that does connect 1 through 10 to the sternum are made of hyaline cartilage, and this allows a degree of flexibility inside the chest. Inside lecture, we'll go back over the idea about how this relates to things such as CPR. It's really important that you have some flexibility in there, so there's a possibility of doing a compression without necessarily breaking ribs. More later. AC here, that was costal cartilage. AC stands for articular cartilage, and the articular cartilage is what's found at the ends of the bones. In essence, it's sort of like a padding at the ends of the bones. It provides a little bit of cushion, a little bit of a slippery surface, and this is where synovial fluid is sometimes located in a synovial cavity in a synovial joint. EP here stands for Epiphyseal Plate. The epiphyseal plate, sometimes known as the growth plate, is located in the metaphysis of the bones, and this is an area where there's still hyaline cartilage, where there's still the possibility of the bone growing longer. For fibrocartilage, in reference to the skeletal system, we have intraventricular disc. These are the pads located between the bodies of the vertebrae, and it acts as a cushion to take much of the weight that is being expressed here. These intervertebral discs are the ones that are sometimes problematic when they slip or they bulge. Much more about that later on. The pubic symphysis, or symphysis pubis, is a pad of fibrocartilage located between the two pubic bones. This is the anterior connection of the pelvic girdle, and there's a slight degree of flexibility right here. If the pubic symphysis wasn't there, if there was solid bone right there, taking a step might put so much stress in this region that you would break it easily. And of course, as we get older, that's always a possibility of the pubic symphysis losing some of its flexibility. We'll also make a reference in class to during delivery, childbirth, a hormone called relaxin may be produced, which will cause the pubic symphysis to become a little more flexible and to allow the two sides of the hip to rock a little bit relative to each other. However, there's still the sacroiliac joints back here, which will create a problem that we'll talk about later. And then there's the meniscus right here. The meniscus on the top of the tibia. And again, there's a huge amount of pressure right here because every time you take a step, the entire weight of your body above that point, including the opposite leg, is pressing down in this region right here. The meniscus is particularly problematic when it comes to athletes who tear this meniscus, which is a cup-like or curb-like structure that prevents the femur from slipping too easily laterally, although there are other tendons and ligaments that help stabilize it too. Finally, right here, let's say something about the dense regular connective tissue. And the dense regular connective tissue represents ligaments and tendons. Of course, by general definition, a ligament is a strap of dense regular connective tissue that connects a bone to a bone. And a tendon, by general definition, connects a muscle to a bone. And even though that may be the definition straight out of the dictionary, there are times in which we, mess up that definition. It just, historically, people have used it wrong. So we'll learn what it's supposed to mean, and then we'll also be patient when we see that somebody else has misidentified something, but they wrote the book, and they put those names inside the book. So here we got a bone and a bone. There's a ligament connecting the two. Here we got a muscle and a bone. There's a tendon connecting the two. A curious little way of remembering all these strange pieces of the skeletal system is to think about a turkey or a chicken after the meal. After you've taken all the muscle off that carcass that you possibly could, the thing that's left behind, that strange puppet of bones and sinew, ligaments, tendons, cartilage and such, that's the throwaway stuff, that was the skeletal system of the animal. Okay, let's stop that one for a second.